Hi everybody, welcome back to Beginning Algebra. Today we're in section 6.4 talking about factoring trinomials using the FOIL method. Now before you start this lesson, you need to make sure that you fully understand how to factor basic trinomials, which is what we learned how to do in section 6.2. If you don't know how to factor a trinomial at all, please go back to the video for section 6.2. But if you can factor those beginning trinomials, then you're ready to move ahead into section 6.4. Now in section 6.2, we learned how to factor trinomials, but every trinomial we looked at, the leading coefficient was 1. In this section, we'll be using the same basic method that we used last time, but the difference between these problems and those is that the coefficient of the first term in this section will now be something other than 1. So these trinomials are going to be just a little more complicated than the other ones, but it's kind of like moving to the next level of a video game. You can do level 2 if you've mastered level 1. You're just adding a little more complexity in level 2. Since we are already familiar with the method that we'll be using, let's just jump right into example 1. Here we have the trinomial 2x squared plus 7x plus 6. Now the first thing we want to do when we start to factor a trinomial, especially if the coefficient of the first term is anything besides 1, is that we want to look at all three terms and see if there is any GCF besides 1. Because if there is a GCF, we want to factor that out first. So we're just going to continue that habit of always checking for a GCF first. Here we have coefficients 6, 7, and 2. Nothing besides 1 goes into all three of those numbers. Also notice that x is not a common factor for these terms because the last term does not contain an x. So for this trinomial, the GCF is 1, and basically there's nothing for us to factor out. So we can go ahead and set down our two empty pairs of parentheses. Now remember, we are reversing the FOIL process. So first times first has to be 2x squared. So we have to choose factors here that when we multiply them together, they'll make 2x squared. The only factors that will give us a 2 are 2 times 1. And of course for x squared, we would use x times x. So let's put here 2x times 1x. Now notice that I did not write the 1 because you know that whenever the coefficient is 1, we just don't bother to write it. Alright, then the next step in our process is that we look at the sign of the last term. If this sign is positive, it tells us these two signs in the binomials will have to be the same. And if they are the same, they'll both have to be the same as the middle term. So we need to put two plus signs in our parentheses. Now the last term is 6, so last times last is going to have to make 6. So let's list the factors of 6. 6 could either be made by using 1 times 6 or 2 times 3. Now because of this 2 here in this first term, the order that we put these factors in is going to have an effect on our middle term. That's never been the case before. You might be one of these students who's gotten in the habit of saying, I'm going to look for two numbers that multiply to give me 6, but they add up to 7. If you do that here, you will get the wrong answer. You don't need these two numbers to add up to 7. You need outer plus inner to add up to 7x, and there's a difference because of this 2. So let's just choose two of these factors and put them in our binomials and see what we get for a middle term. So I'm going to choose the 2 and the 3, and I'm going to put the 2 here and the 3 here. And now let's check our middle term. Outer times outer is going to be 6x. Inner times inner is going to be 2x. So the middle term for the way I have this arranged would be 6x plus 2x, which is 8x. But that is not the middle term that I wanted. Now remember, because of this 2, changing the placement of these two numbers is going to have an effect on the middle term. So let's just cross that out. And let's go again. And let's this time put the 3 here and the 2 here. And let's try the middle term again. So outer times outer this time is going to be 4x, and inner times inner this time is going to be 3x. Together, 4x plus 3x will add up to 7x, and that is the middle term we wanted. And so that tells me that this is the factoring that we were after. Now, I just want to say a little bit about showing your work. I know that if you were working this on paper just for yourself, and probably when you've seen this in class and your teachers worked these on the board, they probably didn't strike through the first attempt and write a second attempt. They probably just erased these numbers and fixed what they already had. That's fine if you're working on paper, but you guys that are going to be showing your work in MyLabs Plus, it is very helpful to the person who's grading your work if you will kind of leave them a trail that shows what your thought process was. See, a teacher who reads this can say to themselves, okay, that student tried the numbers this way, it didn't work, so they crossed it out and tried again. If all you do is erase the two numbers that didn't work and put in two new numbers, and you still for some reason make a mistake and miss it, then your teacher doesn't know if you forgot to try these two numbers, or you didn't know you could try these numbers, or if you tried them and figured out that they were the wrong answer. See, every little bit of information helps. So I very much want to encourage you, instead of deleting your work and just leaving the correct answer, just strike through the attempts that didn't work and then put the correct answer, and that helps your teacher give you the most partial credit they can give you in case you make a mistake. So now let's look at example 2, and we're going to just keep using this same process over and over. For part A, we have 8p squared plus 14p plus 5. Let's first see if there is a common factor that needs to be factored out. Notice that p is not common to all three terms, so that's good. Notice that there is nothing besides 1 that goes into 8 and 14 and 5. So there's no GCF that we need to factor out, and we can go ahead and set down our two empty pairs of parentheses. Now, for this problem, the first term is 8p squared. So right away you have to make a choice. You have no way of knowing whether you should put down 4p times 2p or whether you should put down 8p times 1p. Either one could be correct. The method that I use to decide is I always go with the two numbers that are closer together unless the middle term is something extremely large, and then I would probably put down 8p times 1p. But for this one, because 14 is really not that big of a number, I'm going to go ahead and put down 4p times 2p. If I can't find a pair of factors that will work using 4p and 2p, then I will erase these and put in the 8p and the 1p. But let's see what happens here. So we've got our first times first. Our last term is positive, and that tells us that the signs here need to be the same, so they're both going to have to be plus. Now, last times last has got to make a 5, and there's only one pair of numbers that you can multiply together and get 5. So it's got to be either 1 here and 5 here, or the other way around. It might be 5 here and 1 here. So the only way to find out which arrangement works is to make a guess, put the numbers in there, and see what kind of middle term you get. So let's put down 1 and 5 and see what we get. For this arrangement, outer times outer is going to make 20p. Inner times inner is going to make positive 2p. Together those two make 22p, and that's not the middle term that I was after. So now instead of erasing this, I'm going to leave it kind of as a trail of breadcrumbs. So we're going to just strike through that, copy down our setup again, and let's just change the order of the 1 and the 5. So I'll put the 5 here and the 1 here. And now when we try the middle term, we get outer times outer is 4p, inner times inner is 10p. Together those add up to 14p, which is what we wanted. And so that tells us that this is the correct factoring. Now let's try part B. Again, let's always make a habit of checking first for a GCF. So ask yourself if p is common, and it is not. Now ask yourself if there's anything that goes into 6 and 19 and 10. And there's not anything besides 1. So there's not a GCF that we need to factor out. And we'll go ahead and set down our 2 empty pairs of parentheses. Now 6p squared could be 3p times 2p, but it could also be 6p times 1p. And we just have to make a choice of which one we think is going to get us to the answer quicker. If we try one of them and it doesn't work, we'll have to try the other one. So let's go ahead and set down 3p times 2p. Keep in mind that if I'm not able to find the 2 factors that work using these 2 factors, I'll have to start over using 6p times 1p. Now, the last term is positive. That tells us that the signs here in our binomials need to both be the same, and they both need to be the same as the middle term. Now, last times last has got to make 10. And our choices for 10 are either 1 times 10 or 2 times 5. So we need to just choose a pair of numbers, put it in here, see if we can get the right middle term. If we don't get the right middle term, we'll change the order and try again before we cross out that pair of numbers and try the next. Now I'm going to try the 2 times the 5. And I'm going to put the 5 here and the 2 here. And let's check our middle term and see what we get. Outer times outer is going to be 6p. Inner times inner is going to be 10p. That's going to add up to 16p, which is not what we wanted. We need the middle term to add up to 19p. So we're going to cross that out, put our setup down again, and try reversing the order of these numbers. So let's put the 2 here and the 5 here. You know, this is very much like putting a jigsaw puzzle together. If you try interlocking 2 pieces and they don't fit, you turn the pieces around and try interlocking them a different way. If they still don't fit, you put those 2 down and pick up 2 other pieces and try. So that's kind of what we're doing here. Let's check the middle term here and see what we get. So outer times outer is going to be 15p. Inner times inner is going to be 4p. Add those together and we get the 19p that we needed for the middle term. So that's good, and that means that this factoring is correct. Now there is a trick that you can use to help you cut down on the number of possible trials needed to find the correct arrangement. Sometimes this trick helps and sometimes it just doesn't help, but it can never hurt you as long as you make sure that there's no GCF in the trinomial first. Okay, so here's the trick. Remember that if the trinomial does not have a GCF, then the factors also cannot contain a GCF. That is a very powerful idea that's going to save us a lot of time. If the trinomial does not have a GCF, then the factors also cannot have a GCF. So let's look at example 3. Here we have 6x squared minus 11x plus 3. Now notice that x is not common to all 3 terms, and nothing besides 1 goes into all 3 of these numbers. So there's no GCF here that we need to factor out. That's good. That means we can set down our 2 empty pairs of parentheses, and we can choose a pair of factors to represent 6x squared. Now remember, 6x squared could either be 1x times 6x, or it could be 2x times 3x. I'm going to start off here by putting down 3x times 2x. Now this last term is positive, which tells me the signs here need to be the same, and they both need to be the same as the middle term. So I'm going to have 2 minus signs here. And now last times last is 3. So the numbers I put here have to multiply together and make 3. The only possibilities are 1 and 3. But remember that because our trinomial does not contain a GCF, I don't want to create a GCF by putting the 3 here. Can you tell that if I had a 3 here, 3 would be a common factor for this parentheses? We do not want that to happen. So I know in advance that I may as well not put the 3 here. It's not going to work. So I could put the 1 here and the 3 out here. And now let's check our middle term and see what we get. Outer times outer is negative 9x. Inner times inner is negative 2x. Together, negative 9x and negative 2x add up to negative 11x, which is exactly the middle term that we wanted. So right out of the box on the very first try, we found the correct arrangement of terms. Now let's try part B, and I think this is a really good time for you to pause the video and try working this one by yourself, and then we'll go through it together. Okay, here we go. So first I want to see if there is a GCF. So I look at the 9, the 21, and the 10, and there's nothing besides 1 that goes into all three numbers. Also, I notice that x is not common to all three terms. So the GCF of the terms in this trinomial is 1, and there's not a GCF that we need to factor out. So I'll go ahead and set down my two empty pairs of parentheses. Now first times first is 9x squared. That might be 9x times 1x, but it also might be 3x times 3x. So I'm going to just start by putting down 3x times 3x. Now the last term is positive, so that tells me the signs here need to be the same. And if they are both the same, then they'll need to be the same as this middle term. So I'm going to put down two minus signs. And now last times last is 10. So our factors for 10, of course, are 1 times 10 or 2 times 5. Let's just choose a pair of numbers and stick them in here and see if we get the middle term we want. Now this time, because neither 2 nor 5 has a common factor with 3, our trick that we learned up here really doesn't help us, and we will literally just have to guess as to where these go and then move them if they're not right. So I'm going to put the 2 here and the 5 here. And let's check our middle term. Outer times outer is going to be negative 15x. Inner times inner is going to be negative 6x. Together those add up to negative 21x. That's what we needed them to add up to, so that's the correct middle term, and that means this is the correct factoring. And we really just got lucky here that we put everything in the right place the first time. I don't want you to feel like you have to know in advance where to put the numbers. The whole idea is that we don't know in advance where to put the numbers usually, and we have to just put them in there, see if they work, and if they don't work, we have to try something else. Now here is example 4, so we're still using the same method. Let's factor each of these trinomials. Here we have 8x squared plus 6x minus 9. Notice that there's nothing besides 1 that goes into all three terms. X is not common, so there's no GCF to factor out. So we'll start by putting down our two empty pairs of parentheses. Now 8x squared could either be 8x times 1x, or it could be 4x times 2x. Let's go ahead and put down the 4x times the 2x. Now the last term is negative. So that tells me that the signs in the binomials will need to be different. You cannot know in advance whether the plus goes here or here. You just have to put down two different signs, and if they don't work, you'll know. But just start by putting down two different signs. Now last times last made 9, so let's list the factors of 9. It either could be 1 times 9 or 3 times 3. Let's start out by putting 3 and 3 in our parentheses, and let's check our middle term. So now outer times outer would make negative 12x. Inner times inner would make positive 6x. Together, negative 12x plus 6x adds up to negative 6x. But we wanted positive 6x. So when this happens, and when you get the wrong sign but the right number, all you need to do is change the signs in the binomials. So all we're going to do is erase the signs we have, and where we had a minus, we'll put a plus, and where we had a plus, we'll put a minus, and let's try the middle term again. Now outer times outer is positive 12x, inner times inner is negative 6x. 12x minus 6x does give us the positive 6x we needed, and so now we can see that this factoring is correct. Now I did this rechecking of the middle term with you here, and I'll do it a couple more times, But honestly, once you've changed the signs, you can take it for granted that your middle term is going to work now. So if your middle term adds up to the right number but the wrong sign, change the signs and that will fix the problem. Okay, now part B. Here we have 6m squared minus 11m minus 10. And notice that there's nothing besides 1 that goes into all three terms. So we can go ahead and set down our two empty pairs of parentheses. Now 6m squared might be 6m times 1m, but it also could be 2m times 3m. And we don't really have a way of knowing which is right, so we just make a guess. I have put down here my 3m and my 2m, and now I'm going to put down my signs. So the last term is negative. That tells me that the signs here need to be different. Again, I don't know whether the plus should go here or here. I just know that one has to be a plus and one has to be a minus. So I'm just going to put down the minus and the plus in no particular order. And now let's put in our factors for 10. So 10, you know, can either be 1 times 10 or 2 times 5. I'm going to start with the 2 and the 5. If I can't find anything that works, I'll go to the 1 and the 10. Now remember the little trick that we had about creating a GCF in your parentheses. Our trinomial does not contain a GCF. Therefore, we know that the answer will not contain a GCF either. So when I think about where to put the 2 and where to put the 5, I know that the 2 can't go here because the terms 2m and 2 would have a GCF. So if I'm going to use 2 and 5, I need to put the 2 here and the 5 here. And now let's check our middle term. So outer times outer is going to be positive 15m. Inner times inner is going to be negative 4m. Those add up to positive 11m. So again, I have the right number that I needed, but I have the wrong sign. It's positive 11m and I need negative 11m. So all I have to do is change the signs. And so I'll change this minus to a plus and this plus to a minus. And let's check the middle term again. Outer times outer is negative 15m. Inner times inner is positive 4m. And therefore the middle term will add up to negative 11m. And that's correct. And so this is our correct factoring. Now here in example 5, we have a couple of trinomials with two variables. Remember that this does not change the method or the process that we use. It's just that when we put in our numbers for last times last, they will have to contain variables as well. So first let's look for a GCF. Here we have coefficients of 12, 1, and 20. Nothing besides 1 goes into all three numbers. And we notice also that A is not common to all three terms, and B is not common to all three terms. So there's no GCF besides 1. We'll go ahead and set down our two empty pairs of parentheses. Now we have to make a guess for 12a squared. There are several pairs of numbers that will make 12 when you multiply them together. We could have 1a times 12a, we could have 2a times 6a, or 3a times 4a. The pattern that I like to use is I always like to start with the two numbers that are closest together and work my way back up the list. So I'm going to start by putting down 3a times 4a. If I'm not able to find the right factoring using these two factors, then I will get rid of these and put in maybe 2a times 6a next. But the point is you have to try all the combinations before you give up. So we have our first times first. Let's get our signs. Since the last term is negative, that tells me that the signs in the parentheses will need to be different. I'm going to put down a plus and a minus. And again, I don't have any way of knowing that this is the right arrangement. I just know that at the end, when I check the middle term, if it's not the right arrangement, I'll be able to change it then. Okay, now last times last has to make 20b squared. So the factors of 20 are either 1 times 20, 2 times 10, or 4 times 5. And to get 20b squared, of course, we would need to use like 4b times 5b, 2b times 10b, etc. So just remember we'll have to have b's on these factors when we put them here. Let's start with the 4 and the 5. And notice that I know in advance that I can't put the 4 here because that would create a GCF, and the answer will not contain a GCF because the problem did not contain a GCF. So I'm going to have to put the 4b here and the 5b here. Now let's check our middle term. And so for outer times outer, we're going to get negative 15ab. For inner times inner, we're going to get positive 16ab. Negative 15 plus 16 gives us positive 1, so we'll end up here with positive 1ab. We needed it to be negative 1ab. So again, the sign is wrong. And to fix this, all we have to do is change the signs. So this plus will become a minus, this minus will become a plus. And now, just for the record, we'll check the middle term. But remember that when you do this on your own, you really don't have to check again. It's going to work. So outer times outer is positive 15ab. Inner times inner is negative 16ab. That's going to add up to negative 1ab, which is what we needed. And so this one is now correct. And here's part B. We have 2x squared minus 5xy minus 3y squared. Nothing goes into all three terms except 1. So we'll go ahead and set down our 2 empty pairs of parentheses. Now first times first has to make 2x squared. So of course that's got to be 2x times 1x. Because this last term is negative, we know the signs in our parentheses will need to be different. So I've just put down the plus and the minus, and I'll change them if I need to. Now to get 3y squared on the end here, we're going to have to use 1 times 3 to make the 3. So it's either 1y times 3y or the other way around. It might be 3y times 1y. Our GCF trick really doesn't help us here because if you put the 1y here, you will have a GCF of 1, but that never makes any difference. Every expression has a GCF of 1. So here our trick doesn't really help us. We'll go ahead and put the 3y here and the 1y here and see what happens. So now on the middle term, outer times outer is going to be negative 2xy. Inner times inner is going to be positive 3xy. Together, those are going to add up to positive 1xy. So that's definitely not the middle term we were looking for. Let's cross those out and try again. So I'll just put down the same setup. And this time I'm going to put 1y here and 3y here. So this time outer times outer is going to make negative 6xy. Inner times inner is going to make positive 1xy. Add these together, negative 6xy plus 1xy is negative 5xy, which is exactly the middle term we wanted. And so this factoring is correct. Now, we've been checking for a GCF all along. If you do find a GCF, be sure to factor it out first. The biggest mistake I see beginning algebra students making with factoring in this section is that they forget to factor out the GCF first, and therefore everything is harder than it has to be. If you reverse the FOIL process without removing the GCF, you might find the right answer, but you're going to have a lot more work to do because, for one thing, removing the GCF makes the numbers smaller and easier to work with. The other problem is, if you're able to factor the trinomial without removing the GCF and you leave it in your final answer, you're going to lose points because your answer will not be fully factored. And it's very important that all of our factors in our answer be fully factored. Also remember that the GCF must appear in the final answer. It is part of the answer, so don't lose that GCF. Okay, so here is example 6. We have 15y to the third plus 55y squared plus 30y. Now I hope it is a big red flag to you that our exponent here is not a 2, because you know on every trinomial we've done, we've started with a squared term, and here we have a third power term. So we know something is up. And notice now that y is common to all three terms. So definitely our GCF needs to contain a y. But also notice that 5 will go into each of these numbers. So let's put down a GCF of 5y, And let's undistribute that 5y, or in other words, factor out a GCF of 5y. So to make the first term, 5y times 3y squared would make 15y to the third. For the second term, 5y times 11y would make the 55y squared. And for the third term, 5y times 6 would make 30y. Now you need to always look at your trinomial again and make sure that you really did factor out the biggest common factor that you could. If we still had a common factor in here, it would cause problems. So the whole idea is remove the biggest common factor that you can. And we've done that. There's nothing now that goes into 3 and 11 and 6. And notice that y is no longer common to all three terms. Okay, so now we're going to keep the 5y and we're going to break down our trinomial into two binomials. First times first has got to make 3y squared, so that means we're going to have to put here 3y times 1y. The last term is positive, so that tells me these signs here must be the same, and they both have to be the same as the middle term, so put down two plus signs. Now last times last has to make 6. The choices are either 1 times 6 or 2 times 3. Remember that we have to be careful where we put the numbers because we don't want to create a GCF in these parentheses because this trinomial that we're working on does not contain a GCF. So I'm going to start by using factors 2 and 3, and I know that I can't put a 3 here because of this 3. So I'm going to put a 2 here and a 3 here, and I'm going to check my middle term. So outer times outer is 9y. Inner times inner is 2y. That adds up to 11y. That's what we wanted it to add up to. So the middle term of the trinomial we were working on was 11y. So that means that we chose the right two factors on the first try, and that means that this is the right factoring. And again, it's very important that you have all of these factors. A bad habit that a lot of students have is they take the GCF and they just throw it away, and then they want to put just their binomial factors down as the final answer. But if you multiplied these binomials together, you wouldn't get this top expression that we started with. You'd get 3y squared plus 11y plus 6. So the answer is all of the factors that it takes to multiply back together and get back to the problem we started with. Now let's look at part B. And probably the thing that stands out to you when you first look at part B is that it starts with a negative. And you may be thinking to yourself, well, wait a minute, every problem that we've done so far, the trinomial has always started with a positive term, and now we've got a negative term. Yes, you are correct. Every trinomial we factored has started with a positive term, and we want them all to continue to start with a positive term. So anytime your trinomial starts with a negative, you can just remember that you can factor out a negative anytime you want to. So that's what we're going to do here. We do have a GCF here. Even if we didn't, we would want to factor out this negative. And so we're going to start building our GCF. We know we want it to be negative to remove this negative sign on the leading term. Now let's ask ourselves, what goes into 24 and 42 and 45? Well, I know that 24 is 3 times 8. I know that 42 is 6 times 7, and therefore I can work it out where 42 is 3 times 14. And I know that 45 is 3 times 15. So I know that 3 goes into all three of these numbers. So 3 will need to be part of our GCF. And now notice that A is common to all three terms, so we will need A to be part of our GCF. Now we need to get a look at the trinomial that's left once we factored out negative 3a. So negative 3a times positive 8a squared would make negative 24a to the third. And then negative 3a times positive 14a would make negative 42a squared. And then negative 3a times negative 15 would make positive 45a. So now we have our problem broken into negative 3a times this trinomial. And notice that nothing goes into all three terms here besides 1. So we did a good job factoring out the GCF. Now we are ready to break this trinomial down into two binomials. So I'm going to keep the negative 3a in the front and put down my two empty pairs of parentheses. 8a squared, you know, could either be 8a times 1a or 4a times 2a. We really don't have a way to know which is correct, but I'm going to make a guess and start by saying 4a times 2a. Now I do know that the last term is negative, and that tells me the signs here are going to need to be different. So I'm going to put down a plus and a minus. Last times last is 15. So the factors of 15 are either 1 times 15 or 3 times 5. And we just have to make a guess as to what goes here. So I'm going to put a 5 here and a 3 here. And now let's check the middle term and see if we get the 14a that we're looking for. Outer times outer is going to be negative 12a. Inner times inner is going to be positive 10a. Negative 12a plus 10a is going to add up to negative 2a, not the positive 14a that we wanted. So we'll need to change the order of these numbers, and if that doesn't work, we'll need to try something else. So let's recopy our setup, and let's put the 3 here and the 5 here. And now let's try our middle term again. So outer times outer is going to be negative 20a. Inner times inner is going to be positive 6a. That's going to add up to negative 14a. So that's much better. At least we got the 14, and we know that to fix the signs, all we have to do is change the signs. So we'll change this plus to a minus, and we'll change this minus to a plus, and that ought to do it. So now outer times outer is going to be positive 20a. Inner times inner is going to be negative 6a, and that means that will add up to positive 14a, so that's right, and that means that this is the factoring we were looking for. Now here on part C is our first look at a trinomial that does have a GCF, but it's not obvious unless you think about it, because the y is not common to all three terms. So there's no exponent here that's bigger than 2 that will say, hey, there's a GCF. So you just have to be on your toes, and you have to look at these three numbers. And I hope that when you look at a number as large as 36, that you say, gee whiz, that number is so large that it's going to be hard to work with. Yes, whenever the first number is so large that it's going to be hard to work with, that should be a clue to you that there's probably a GCF. So we know that 36 is 3 times 12, 6 times 6, 4 times 9. Several different pairs of factors can make 36. 81 is 9 times 9, and 45 is 5 times 9. So we know that 9 goes into all three of these numbers. So 9 will be our GCF, and we'll factor 9 out of our trinomial. So 9 times 4y squared makes this first term, 9 times 9y makes that middle term, and 9 times 5 makes that third term. Now check again and see if there's still a common factor in there, because if there is, then 9 was not the biggest common factor that we could use. So there's not anything that will go into 4 and 9 and 5, except 1, of course. And so that means we can go ahead and break our trinomial down into two binomials. So first times first needs to be 4y squared. Our choices are either 2y times 2y or 4y times 1y. I am going to start by putting down 2y times 2y. Now the last term is positive, so that tells me these signs will need to be the same, and they need to be the same as the middle term. So I'm going to put down 2 plus signs. Last times last is 5, so really the only pair of factors I can use is 1 times 5. So I'm going to try putting the 1 here and the 5 here. And now let's check our middle term. So outer times outer will be 10y, and inner times inner will be 2y. That's going to add up to a middle term of 12y, which is not what we needed. Of course, we needed 9y. So we're going to need to try again. Now normally I would just change places with the 5 and the 1, But notice that in this case, if we change places with the 5 and the 1, we'll get the same middle term again because these two first terms are the same. So this time, changing places with 5 and 1 won't really help. What we're going to have to do is, instead of trying 2y times 2y, we're going to have to go back and try 4y times 1y. But our signs will still both need to be plus. Now I'm going to put down the 1 and the 5 again, and let's check our middle term again. So outer times outer is going to be 20y, inner times inner is going to be 1y. So that's giving us a middle term of positive 21y, which again is not what we needed. So let's try one more time. And this time we'll keep the 4y times the 1y, but we'll just change places with the 5 and the 1. And let's see about this middle term. So outer times outer is 4y, inner times inner is 5y. That's going to give us the 9y that we needed for the middle term, so that's right. And that means this factoring is right. Now I want to go through this example with you one more time just to show you what happens if you forget to factor out the middle term. This is very important. So even though I don't want you to do it this way, I want you to follow me through this example so you'll know what's going on later and you'll be able to keep yourself from doing this. So if you did not first think about factoring out a GCF, then you would just set down your two empty pairs of parentheses and go to work. And you would say, okay, this is going to be hard, but 36 is going to be either 1 times 36 or 2 times 18 or 3 times 12, 4 times 9 or 6 times 6. And that is a lot of factors to try. But let's just start with 6 times 6. So we'll have 6y times 6y. The signs are going to need to be the same, both plus. And now the numbers we put here have to make 45. And so 45 could either be made of 1 times 45 or 3 times 15 or 5 times 9. Let's just start with the 5 and the 9. So I'm going to put 5 here and 9 here. And let's check our middle term. And that's going to be outer times outer, which is 54y. Inner times inner is 30y. Together those make 84y. So not the middle term we were looking for. Okay, so we cross that off. And we know that switching the 9 and the 5 won't do any good because both of these first terms are 6y. So there's no need to try switching. We'll just go ahead to the next pair of numbers, which is 3 times 15. And notice that we're having to ignore our little trick about not creating a GCF in the parentheses because this trinomial does have a GCF. So that's why I'm telling you, before you use that trick, you always need to make sure that your trinomial does not contain a GCF. But let's go ahead and add up the middle term for this arrangement. And outer times outer is going to give us 90y. Inner times inner is going to give us 18y. Outer plus inner then is definitely not going to add up to 81y, you can tell. And so we know that this pair of numbers didn't work. I don't think there's any need in even trying the 1 and the 45 because you can see if you put 45 here, 6 times 45 is going to be way too big, so that would just be a waste of time. I think all we can do at this point is abandon the 6y times 6y and try something else. Let's try 4y times 9y. And let's go back and try 5 times 9 again. So I'll put a 5 here and a 9 here, and let's check our middle term. Outer times outer is going to be 36y. Inner times inner is going to be 45y. And that is going to add up to 81y, which is what we wanted. So it looks like this answer is right, but when you put this on your test and you get your test back, you'll see that it'll get counted wrong. It's not that the outer plus inner doesn't work. It does. The problem is you would get partial credit on this answer probably. This factor is not completely factored. Remember, our instructions always say factor completely, and this is not completely factored. So what needs to happen here is that you need to factor out of this parentheses a GCF of 9. So I'm going to undistribute the 9 from this first set of parentheses. So 9 times y would make 9y, and 9 times 1 would make 9, and then we can have our other factor. Now if you FOIL this back together and then distribute the 9, you will get that answer. If you FOIL this answer back together, you will get the right trinomial, but again, the problem is that you've left a GCF in one of these factors. So that's why I'm saying it's really, really best every single time if you will start by checking for a GCF. Not only does that make the problem easier to work because it makes the numbers smaller, but it also will keep you from falling into this trap where you accidentally leave a factor in your answer that still contains a GCF.